Hello there, wind energy students. Dr. John Schragi, and I just got back from dropping my wife off at the Evansville Regional Airport, which is every bit as impressive as it sounds like it would be. It's not exactly a bustling hub of the airline industry. And when I was there, I was thinking about the fact that the stuff that we're doing in this module seems like it would have a lot to do with aviation meteorology. I mean, we're going to be talking about the wind profile. But here's the deal. The wind profiles that we're talking about in this module of the course are boundary layer phenomena. And in particular, they're going to be like the very bottom. Remember we used the term the surface layer when we were first learning about boundary layer meteorology and so on? These are going to be the lowest, maybe 100 meters above the ground or something like that. Well, an aircraft is going to pass through that in seconds of takeoff and landing. It's not going to have a huge amount of impact on like aviation. Now, wind profiles do matter, like higher up in the atmosphere and at a cruising level and things like that in an aviation context. But when we're talking about it in this class, we're talking about it in a wind power context, and obviously that would be a lot higher up than our wind turbines are going to be. So we're really talking about the wind profile, how the winds are changing with respect to height in the lowest maybe 100 meters or so above the surface of the Earth. And that's going to be a function very strongly of a phenomenon we call the static stability of that layer. And we're going to have to learn about what the static stability means and why it's important and how we measure it. And it turns out there's a whole mess of ways that we measure the static stability. And then we're going to have to talk about the different wind profiles we're going to expect if the lowest layer of the atmosphere is statically stable, statically unstable, statically neutral. How did it get to be statically stable, statically neutral, and statically unstable, or whichever? I lost track which ones I was saying there. And how is a wind profile going to change as we go from one location to another? The wind profile is going to have a lot to do with friction at the surface, like, how rough is the surface the wind is blowing over and so on. Well, that's a complicated story when we're talking about like the wind blowing onshore across Lake Michigan and into Chicago. I mean, we're going to have very different roughness over the city than over the lake and so on. We're going to have different fluxes of heat from the lake than we do over the city and so on. How do we decide what that all means? That's what this module's about. You're also going to do a little bit about Mononobenkov theory, although we're not going to get just too bogged down in that at this point in the course. We're going to kind of double back to that when we need it more explicitly in the future. And we're also going to, in the discussion this time, sort out something that I kind of lied to you about a little bit in actually the first lecture of this module. You're going to be sorting out something about vertical gradients in the Earth's atmospheres and how something changes with respect to height. Something I tell you in the first lecture is actually kind of an oversimplification, which doesn't sound like Dr. Schragi lying at all. I mean, that he never does that. Anyway, so you're going to get that sorted out in that part of the module as well. Anyway, Module 4 is kind of a fun one. It definitely kind of relates very explicitly to wind power. I think students will enjoy it. Please let me know if you have any questions about it.